Welcome back students in the second part of this series. Here I am going to discuss about the explanation for Archimedes Principle, applications on Archimedes Principle and flotation on the basis of Archimedes Principle. So let's start. The Archimedes Principle states that when a body is immersed partially or completely in a liquid, then it experiences an upthrust, which is equals to the weight of the liquid displaced by it. It means when we take any object and immerse in a liquid, then it displaces a certain amount of liquid. The weight of that liquid which been displaced by the immersed portion of the object is equals to the amount of buoyant force experienced by the body in the liquid. Let's understand more about this with a mathematical proving. Now, let's understand the proving of the amount of upthrust experienced by an object which been immersed in a liquid is equals to the amount of liquid displaced by the object, or you can say the weight of the liquid displaced by the submerged portion of the object is equals to the amount of upthrust experienced by that body. For this, consider a solid cylinder with height h, cross-sectional area A, which been completely immersed in a fluid with density ρ. Then the amount of pressure experienced by the container at h1, means at the top of the container, will be h1 ρg, which been taken from the formula of liquid pressure. Now, as we have to go for upthrust, means force, therefore the amount of force acted at the top of the container is equals to P1 into A, means pressure into area. When you substitute the value of P1, then you will get it as H1 rho G A. Take it as equation 1. Now, similarly, you can calculate the amount of pressure at the height of H2, where the amount of force will be taken as H2 rho G A. Now take this one as equation 2. After taking these two equations, we can calculate the amount of buoyant force, which will be the difference between F2 and F1. Here the amount of F2 is greater than F1 because, as we know, the height is directly proportional to the pressure exerted by any liquid. Therefore, at the bottom, the pressure exerted by the liquid is greater than to the pressure exerted at the top of the container. Therefore, obvious thing that the force exerted at the bottom is greater than to the force exerted to the top of the container. The FB, or the force of upthrust, will become here as the resultant force. When you substitute the value of F2 and F1, then you will get the value as V rho G. Here V is the volume of the cylinder submerged in the liquid. Now, if you change the value of volume of solid immersed in the liquid as to the volume of the liquid displaced, then you will get the formula V rho G as the volume of liquid displaced into density of the liquid into acceleration due to gravity. Now you may think that why that the volume of solid immersed is equals to the volume of the liquid displaced. Now students, remember this thing, that whenever you immerse any object in the liquid, then it will obviously displace equal amount of liquid as per to its volume, because it is creating space for its own shape. Therefore, here also we can change the volume of the solid immersed as to the volume of the liquid displaced. Now, again, when you go for the mathematical proving for the situation, then you need to have the multiply of this volume of the liquid displaced with the density of the liquid, which will result to the mass of the liquid displaced. At the end, when you multiply these two quantities, means the mass of the liquid displaced with the acceleration due to gravity, then at the end you will result with the weight of the liquid displaced by the submerged part of the body. So here you had understood how the amount of buoyant force is equals to the weight of the liquid displaced by the body. Now, let's discuss more on Archimedes' principle. A still ship can float by displacing an amount of water that is equals to its total weight. Here the total weight has been taken as the sum of the weight of the ship as well as the cargo on it. Now how this is possible? This is possible because of the construction of the ship. A ship used to be constructed in such a way that it can displace an adequate amount of water to obtain a certain amount of buoyant force, where we know the amount of buoyant force on an object is equals to the weight of the fluid displaced by the object. With this, we need to understand the situation of flotation and sinking down. The principle of flotation states that when an object floats in a liquid, then the amount of buoyant force that acts on the object is equals to the weight of the object. Now you need to remember these points for understanding flotation. The displaced volume of fluid is equals to the volume of the object which is immersed in the fluid. If the weight of the object is greater than the upthrust, then the object will sink in the fluid. Whereas, if the weight of the object is equal to the upthrust, then the object is balanced, making the object float over there. Such as, for an example, a solid iron 1-ton block may displace 1/8 ton of water and it sinks down, as you can see over here in the figure. But if the same 1 ton of iron in a bowl shape displaces greater amount of volume, then it can balance over there and float. Now, when we discuss about the flotation, then we have to also understand the situation when the object is placed in a fluid. When a body is in a fluid, then two forces are acting on it. A force which is equals to its weight due to the gravitational pull acts in the downward direction, whereas there is a buoyant force which acts in the upward direction, which is due to the liquid pressure. Now, according to the principle of flotation, the weight of a floating body is equals to the weight of the liquid displaced by the submerged part. Here you can say that weight of the floating object or any body is equals to the weight of the fluid displaced, which is also equals to the buoyant force. This we had already understood while we were discussing about Archimedes' principle. Now with all this, you can say that flotation is an equilibrium situation. Now let's discuss flotation on the basis of buoyant force. Buoyant force can be distinguished into three kinds: positive buoyant force, negative buoyant force, and neutral buoyant force. It can be said to be as positive buoyancy also, where we can say a buoyant force which is greater than the weight of the object which been immersed in the liquid. This makes the object float on the surface very evenly, or you can say the object is floating in a very proper manner. Whereas for neutral buoyancy, we have the buoyant force equals to the weight, so that the object is partially sinked or partially floating in the liquid. Whereas we have a negative buoyancy, under which the buoyant force is quite less than the weight of the object which been immersed in the liquid. Therefore, the object completely sinks down in the given liquid. Now, let's discuss some of the applications of the Archimedes principle. Let's start with a submarine. Do you know the reason why submarines are always underwater? It is because they have a component called blast tank, which allows the water to enter to make the submarine be in its position underwater, as the weight of the submarine is greater than the buoyant force. And when the submarine needs to come on the surface of water, it pumps out the water from the blast tank to reduce down its weight, which will be equal to the buoyant force applied by the liquid, and it will be able to float on the surface of water. In the case of hot air balloon, do you know why the hot air balloon rises and floats in the mid-air? It is because the buoyant force of the hot air balloon, which is less than the surrounding air. When the buoyant force of the hot air balloon is more, it starts descent. This is done by varying the quantity of hot air in the balloon. Now let's understand about a hydrometer. A hydrometer is an instrument used to measure the relative density of a liquid. Hydrometer consists of lid shots which makes them float vertically on the liquid. The lower the hydrometer sinks, the lesser is the density of the liquid. I will discuss once again the hydrometer when I will discuss about the relative density.